Okay, in this video we're going to have a look at graphs of exponential functions. Okay, and they're in the form of y equals a to the power x. Okay, this is what it generally looks like here, and we're saying that's what it looks like when a is greater than 1. Okay, so when this base number is greater than 1, it's going to look something like this. Okay, as we've seen previously with some of our other functions like our hyperbola or truncus, okay, we have a horizontal asymptote here. So the graph will approach this asymptote here as x gets more and more negative. Okay, so as x approaches negative infinity, the graph approaches 0. So we can see there that there are no x-intercepts, but we have this y-intercept there at 1. Okay, an example of this would be y equals 2 to the power of x. Okay, it would look something like that. Now to note as well, we also go through the point 2. We go through the point 1, 2. Because of that base value being 2 for this one. Okay. When we have a look though at what happens when a is between 0 and 1, okay, we still get a y-intercept at 1. Okay, we still have no x-intercepts. Okay, and the x-axis is still an asymptote, that hasn't changed. But if we ever think about this, if we were looking at, say, y equals half x, remember that half can be written as 2 to the power of 1. Right? And 2 to the power of 1 to the power of x, okay, which is really what would be equivalent there, is equal to 2 to the power of negative x. So really what's happening here, okay, is that we're having a reflection in the y-axis. Okay, is really what's happening here for values between 0 and 1 for our base, this a value. Okay, so similarly, we would actually have this spot here, which was 1 and a half. Okay, we'd have this value 1 and a half in here. Okay, we've got a bit more to look at. Okay. If we have a look here though, we can see that we can do very similar things to our other functions. We include a constant at the end. So this is what we call a vertical translation. So it moves it up and down. Okay, remember, if this value is positive, we're moving the graph up. If it's negative, we're moving the graph down. Okay, and we find then that our y-intercept, okay, is at k plus 1 for this type of situation. We can see here that the the x-axis asymptote there that we had, that was at the x-axis, has now been moved up by this value of k as well. So the whole graph just goes up by this k value. Here we've got a to the x take h. Now this h is that horizontal translation. Now if this is a negative value up there, we actually move it to the right. If it's a positive value, we move it to the left. Remember that? Okay, that hasn't changed, the same as what it's always been for all our other types of graph. Okay, it means though that our y-intercept ends up being at a to the negative h. Okay, so essentially whatever that is in there. Okay, if we were to let y equal 0, we're going to have a to the negative h. Okay, that's going to be our y-intercept for that one. We can see here for this one, and we spoke about this just before with the example we had, a to the negative x, this is a reflection in the y-axis. Flips it this way. Okay, it doesn't change the y-intercept though, and we're still going to have those asymptote down here that is the x-axis. Okay, similarly, if we have a negative at the front, this is actually a reflection in the x-axis, so it's going to flip it down now. Okay, our y-intercept now has to be at negative 1. We're still going to have that asymptote here at our x-axis. Okay, we've got a little bit more we can do though. Okay, so we've got these values out the front here. Okay, so if we've got y equals m times a to the nx, these are both what we call dilation factors. Okay, what will happen is the y-intercept will become this m value. Okay, because this is saying, well, x is 0, n times 0 is still 0, a to the power 0 is still 1. Okay, so we're going to have m for the y-intercept, and the graph will go through this point 1 on n a. Okay, so we've got a couple of examples that we're going to do. This is our first one here. We're going to sketch y equals 3 times 3 to the x take 1. Okay, so we've got some axes here. So I'll be looking at this and going, okay, well, what do I know? Okay, well, this 3 is going to stretch it. Okay, I'm not too worried about that at the moment. Okay, and I'm going to be moving it down by 1. Okay, so I know that my asymptote now is down at -1. Okay, we need to think about what's going to happen for our y-intercept here. Okay, so the y-intercept would be at 3, but now we are coming down 1, so our y-intercept is going to be at 2. Okay, it's positive and this is positive, so nothing, we don't have a problem there. Okay, so we know we're going to be doing something like this. That's at 2. You see here we've got an x-intercept though. Okay, so at this stage we're not going to worry too much about what our x-intercepts are going to be. I'll show you really quickly, but it's going to introduce you to some newer things that we haven't seen before. So what I need to do is still my let y equals 0. Okay, so I'm going to have 0 equals 3 times 3 to the power x take 1. Okay, I need to add 1 on. Okay, I had to divide by 3. It'll be 1/3 equals 3 to the power of x. Okay, now this is a nice answer only purely because we had 3 times 3x. But what our process is here is that we'd have to do log to the base 3 of 1/3 equals x. Okay, and we haven't seen this process before. We're not worried about too much. So I'm putting it here as an example of how you would find it, but the expectation right now is that you don't need to do that. And this itself can actually simplify, and we will find that x equals -1. Okay, this value would actually be -1. Okay, at this stage though, we don't need to worry about that. We haven't seen logs yet. So this is the time that you actually get off the hook a little bit here, and I'm not expecting you to find any of your x-intercepts. Okay, but we need to do another one. Okay, so I'll get another one going. So this time we're going to sketch y equals -2 to the -3 x plus 6. Okay, is the one that we're going to look at this time. Okay, so we need to think about what's happening here. Okay, we don't have a constant at the end, so we don't have a vertical translation. We do have a horizontal translation, but this is exactly the same as any other function. Okay, we have a coefficient of x up here, and I've said this in previous videos. We need to take this out as a factor, so we need to factorize our index up here. So I'm going to take -3 out as a common factor, which is going to make it x take 2. Okay, so we are not moving it by 6 units to the left, we're moving it 2 units to the right. So you can see how much of a difference that is going to make. Okay, now, interestingly though, we have actually got reflections in both the x and y axes. Okay, because we've got a negative here and a negative here. So we're going to get reflected down and we're going to get reflected across. So usually we look like this. Okay, you can think of it looking like this and then looking like that. So we've actually reflected a number of different ways here. Okay, so I'll get rid of those on so we can fix that up a little bit. Okay, so we're actually reflecting 2 directions. This one is actually going to be down like this. Okay, so if we think about now our y-intercept, okay, so remember that's going to be when x equals 0, so that disappears. So we're going to have y equals -2 to the 6. Okay, is what's going to be happening there for our y-intercept. Oops, sorry, this is -2 to the 6. Alright, we're not going to worry about working out what that is. Okay, that's our y and that's our x. Okay, so a really big takeaway from this, I want to show you this example because of this process here. Okay, we've spoken about before with our hyperbolas and truncuses and square root functions, all of those. Okay, as soon as you see that we've got a coefficient of x within our function, we need to take it out as a factor in order to get our translations right in the horizontal direction. Okay, so make sure you're doing that. Hopefully, you won't have too much trouble with graphing these ones.